So in the last class we had discussed about the different biomimetic related system. So where we had discussed about this gecko robot and the overall mechanism which was involved in the gecko robot, which including the locomotion and related applications. And we have also discussed about some of the key adhesive related mechanism which was involved in these kind of gecko based robots. So in today's lecture, so we will discuss about this magnetic swimming micro robot. So as far as these magnetic swimming micro robots are concerned, so these are a class of micro scale robots that navigates and operate inside the human body using an external magnetic field. So we can have a control over the locomotion by giving an appropriate magnetic field to this system, so that we can locomote these objects appropriately. So these robots are particularly useful in targeted drug delivery, minimally invasive surgeries, blood clot removal, and a certain amount of micro scale diagnostics. In fact, this is a kind of an AI generated image which will give you a kind of a clarity like how these magnetic swimming robots are deployed for different applications, like which includes a kind of it has a kind of a rotating flagellum. So these rotating flagellum are mainly meant for a kind of a drug delivery. So it's a kind of a targeted drug delivery can be emphasized using this system. So we will be having a different like parameters which are being involved, which can be appropriately addressed by these magnetic swimming micro robots. So like as far as this micro scale locomotion is concerned, so like before going into the magnetic based micro robots, there is a need to understand the phenomenon behind this micro scale locomotion in fluids. So in this regard, like it is important to consider the Reynolds number when studying the propulsion mechanism in the fluidic environment. So as far as these Reynolds numbers are concerned, these Reynolds numbers are defined by the density, the velocity, the characteristics length, as well as the viscosity. So when we consider this Reynolds number, it is a measure of the ratio of the inertial to viscous force in a liquid. So for a small Reynolds number, that is a Reynolds number less than 1, the inertial forces become negligible and the viscous force ideally dominates. However, at a micro scale, both U and L are small, and even in water, which is not viewed as a viscous fluid itself, the Reynolds number is much smaller than 1. So to understand how these microorganisms move in water, we would have to imagine ourselves like swimming in a pool of honey or tar. So it then becomes an intuitively obvious that the swimming techniques must be adapted in order to able to move in such a viscous environment. So these are some of the points which we may need to consider. So now when we try to look into the inertial term, so without the inertial term, the flow can be described by the Stokes equation. So ideally this if we look into the parameters of the Stokes equation, it depends upon the pressure, the velocity field of the fluid, and the external forces on the fluid. So like this is the overall Stokes equation. So this equation is only exact for Re0, but it is considered a valid approximation for Re less than 1, and it does not contain any kind of inertial terms, and the flow becomes perfectly reversible. As it is a linear equation, the superposition of fundamental solution is possible. A direct outcome from the reversibility of the Stokes flow is the fact that perfectly reciprocal the motions but does not create any kind of net motion. So there is a kind of theorem which we call it as a scallop theorem. So basically this scallop theorem has a relevance towards the selection of the Reynolds number. So in that particular aspect, it states that as the Reynolds number Re, it is only the geometric configuration that matters, and it is not the speed and the reciprocation motion which may lead to a net displacement. So ideally this theorem is only true for Re equals 0 and in a fluid with a constant velocity. Now let us see some of the different propulsion mechanisms of microorgans and analogous artificial propulsions of magnetic micro devices. So if we closely observe, so if we consider a kind of a, so we can classify these microorganisms into three. One is a kind of a planar flexible tail. Another one is kind of a helical rigid tail, and the third one is called as a cilia. So when we try to look into this planar flexible tail, it's a kind of a beating of a flexible flagella. It is called as spermatozoa. So it has a kind of a tail which is available over here. So this tail will induce a kind of a propulsion. So ideally, when we try to talk about the micro devices, for example, this kind of, let us consider this as a micro devices which is meant for a targeted drug delivery, so which has a kind of a top head and base, and then we have a kind of a movement for a appropriate system. So in this, so we will be having a planar beating which moves back and forth. Next, we can talk about the rotating rigid helical flagella which is actuated by a molecular motor. Example of such kind of system is called, it is derived from a system which is a kind of a E. coli bacteria. So these E. coli bacteria, so in this particular system, a rotation occurs with reference to the movement of this spring kind of structure. This rotation will be helpful for us to create a locomotion in a particular direction. So now what happens is, there is going to be a contraction and an expansion which exhibits in this rotary movement, owing to which there is going to be a kind of a translation mechanism which exhibits over here. So ideally, you can either have a kind of a theta orientation which exhibits, or you can also have a kind of x and y movement which can be used for the motion of the system. Okay. Now we have a cilia, so which is a kind of a, which is called as paramecium. So as far as in this cilia is concerned, there are a certain amount of small nodes which are available. So the main functionality of these small nodes are, like when it gets actuated, it has its capability towards movement. So this is a kind of a cilia kind of structure which exhibits. Okay, so paramecium is a very good example of this cilia kind of structure. Now let us talk about the other with reference to micro device perspective point of view. So this is a kind of a flexible beam actuated by a torque at a spherical head. So the movement of the flexible beam is actuated by a torque with reference to this particular motion. Then this talks about the rotating rigid helical tail which is fixed to a magnetic head. So what happens is, this rotation moves in an appropriate moment. So this can be used for moving the structure in a particular direction. As far as these artificial cilia array is concerned, it has a flexible micro rods or beams. So the actuation of these structure will be helpful for us to have an appropriate locomotion which is expected. So when we try to talk about the materials which is used for this magnetic robotic perspective point of view, so we have a material type which is called as a magnetic nanoparticle. So some of the examples includes Fe3O4 iron oxide or cobalt based structures which are used for this magnetic nanoparticle based applications. Then some of the key purpose basically includes, it provides an external controllability. And with reference to biocompatible perspective point of view, so there are certain biocompatible polymers. Some of the biocompatible polymers ideally include the PEG, PLGA and hydrogel. And the main purpose of such kind of biocompatible structure is, it ensures a safety interaction with a body fluid and the tissues. Okay. Then the most important perspective point of view is the soft and a flexible material. So these elastomers are shape memory alloy polymers. It helps in smooth movement as well as it takes care of the adaptability of the structures. Now let us see the overall working principle of this magnetic swimming micro robots. These magnetic swimming micro robots are fabricated with magnetic material, like we have this iron, cobalt or nickel based nanoparticles, which are being exhibited. They respond to an externally applied magnetic field to generate a kind of a control motion. So this movement is achieved via a magnetic torque or an oscillation or a helical rotation, mimicking the biological microswimmers, example like bacteria, sperm cells, etc. There are different types of these magnetic actuation is there. One is called as a helical propulsion. Like you might have seen a rotating corkscrew, which when we try to rotate it under a magnetic field. So here, so as far as in this corkscrew is concerned, it will be having a kind of a like a programmed path, and when we try to apply a magnetic field appropriately, this corkscrew will rotate, which will result in a kind of a movement. So some of the examples is bacteria, where we have the E. coli magnetostatic bacteria which are being established. Then in addition to this, we have a flexible tail oscillation. So as far as these flexible tail oscillations are concerned, the major mechanism involves a wave-like tail movement under an oscillating magnetic field. So some of the examples basically includes a sperm-like motion. And then when we try to talk about the other type, where we have the surface rolling or walking system. So as far as these mechanisms are concerned, it has a magnetic adhesion which enables a kind of a surface climbing inside the vessel or tissues. So some of the example in this includes a bacteria like crawling, which exhibits over here, or some of the example which exhibits. So this is how overall the actuations are classified, and the propulsions are classified appropriately for different applications. Now, so this is the overall notations of such kind of magnetic based propulsion, so which we have discussed earlier. So this is a kind of a helical propulsion which exhibits, and this is a kind of a flexible tail oscillation. So basically the movement of the oscillation is termed over here. So if we have an oscillation something like this, so we can have a control over the movement as well as the theta. So similarly, Celia microrobot also have a oscillation in this particular direction for an appropriate movement. And in the case of a helical microrobot, so we have a helical kind of structure. So these kind of helical kind of structure will appropriately expand and contract. The expansion and contraction will have a kind of an influence on the overall movement of the structure. Now, let us see some of the applications of such kind of magnetic robot. So as far as these magnetic robots are concerned, these are widely used for targeted drug delivery. So like these micro robots which deliver the drugs which are directly affected by tissues or tumors, which reduces the side effect, and it is highly used for minimally invasive surgery, which is used for precise microscale intervention inside arteries, eyes and the digestive tract. So it is as far as it has a potential application towards this cancer therapy. So when we try to consider a cancer therapy, instead of it can carry the chemotherapy drugs directly to the tumor and increasing the treatment effectiveness. On an application perspective point of view, a blood clot removal is considered to be one of the applications where the micro robots break down clot inside the blood vessels, preventing the strokes or heart attacks. And then when we try to talk about the cell and the tissue engineering, so these micro robots help in cell transport as well as the cell tissue regeneration are some of the key application of this biomedical magnetic based actuation in the field of biomedical related applications. Now let us discuss some of the challenges in which is observed with reference to this magnetic swimming micro robot. So one of the major challenge which includes the biocompatibility issues. So use of biocompatible coating like PEG or hydrogel or biodegradable polymers to make the micro robot which is safer for medical use. And second point is with reference to control and precision. Implementing AI based real time control and optimized external magnetic field for adaptive navigation is considered to be one of the key solutions for control and precision. Next is the removal after use. So we can design a biodegradable micro robot that break down naturally or use an external magnetic field for a guided retrieval can be considered as one of the key aspects. Next is drug release control. So use a stimuli responsive drug carrier that release drug in a response to pH and temperature or external signals. Next is with respect to SWAN coordination. So implement of kind of a SWAN intelligence algorithm for a synchronized and an autonomous movement is considered to be like one of the key challenges which can be addressed with reference to this magnetic perspective point of view. Now, we will discuss about the acoustic actuated micro robot. So, in the previous cases, wherever we had a magnetic base, so appropriately it is used for a targeted delivery. Magnetic base with respect to biomimicking perspective point of view, these are the three different propulsions which are well explored and which are being implemented for a targeted drug delivery related application. Now, let us discuss about the acoustic actuated micro robot. As far as this acoustic actuated micro robots is concerned, the principal operation of these acoustic actuated micro robots are ideally driven by the sound waves. So, typically in the ultrasonic frequency range of sound waves are ideally considered for such kind of acoustic actuated micro robots. So, utilizing these acoustic force for propulsion and manipulation, like we have discussed a lot about this acoustic based manipulation in the earlier modules also. Now, here we will be focusing on acoustic based actuation, in particular towards biomimicking related applications. As far as mechanism perspective point of view, they move through the mechanism like acoustic streaming, radiation forces, bubble oscillations, or resonance induced vibration. As far as the key advantages is concerned, they offer a remote, a wireless control, and most important aspect perspective point of view, it can operate in complex fluids, like it can be manipulated or it can be propelled in the region of blood or biological media, and it is a kind of a minimally invasive system. On an application perspective point of view, it has a potential use including targeted drug delivery, microsurgery, biosensing, environmental monitoring, and microassembly related structures. With reference to material choices, as far as these particular aspects are concerned, with reference to acoustic actuation perspective point of view, so there are certain sets of materials which we may need to consider for appropriate movement. So these micro robots are often fabricated from a biocompatible materials like polymers, metals, or composite to ensure safe interaction with biological environments. As far as navigation and control perspective point of view, by tuning acoustic parameters like frequency and amplitude and using a phased array or pattern field, precise motion control and swarm behaviors are quite easily achievable with this navigation control. Challenges perspective point of view, like some of the key challenges which includes controlling micro robots individually in swarms, achieving a propulsion efficiency at small scales, and ensuring stability in variable biological conditions. Some of the recent advances are integration with other actuation methods, like example magnetic field, light, and development of smart and multifunctional robot in enhancing the performance and versatility are considered to be some of the recent advances with reference to these particular systems. Now, let us discuss about the overall classification of these acoustic actuated micro robots. So, when we try to classify these actuation based micro robots, so based on the acoustic actuation, we can classify as a bubble propulsion system, a sharp edge propulsion system, and an in situ micro rotor based acoustic actuated micro robots. Let us discuss in detail about the mechanism and the principle involved in it. So, first let me discuss about the bubble propulsion. So, as far as these bubble propulsion perspective point of view, like we have discussed in our earlier micro propulsion mechanism also, by creating more amount of high frequency bubbles, so we can create a kind of a propulsion which can exert. Like for example, so let us consider a kind of a floating object. By giving a bubble from the back side as well as from the side, so appropriately we can have a kind of a control over the manipulation of that floating object. So in fact, let us consider the floating object seems to be as some kind of structure, something like this, where there is a kind of a drug which is being kept into it, and it's a kind of a tube or a capsule kind of structure. So in this capsule kind of structure, by just giving inducing a bubble in this particular direction, appropriately we can have a manipulation. So As far as these bubble propulsions are concerned, it has a long-lasting armored microbubble under a force vibration. So, let us consider this as the structure. So, this structure comprises of two different tubes. One is a short tube and another one is a long tube. So, there are two bubbles. One is a center bubble in the short tube and there is an inner bubble along the long tube. There is a magnetic which is also being placed in such a way that whenever there is a kind of a deviation is there, or whenever there is a kind of a precise control needs to be implemented, in order to cater the propulsion appropriately, magnetic fields are applied and then an electromagnetic waves are deployed into it. So, if you closely observe the overall mechanism which is described in this schematic, so let us consider the payload system as this. So, basically this is a kind of a small micro robot which has the targeted drug which is being placed over here by applying a kind of a magnetic field as well as by applying a kind of a forced vibration from the micro bubble. Appropriately we can observe a movement of these particular capsules moving in a particular orientation or in a particular path. Okay, so these are called as a long lasting armored micro bubble which are being manipulated using a force vibration based system. Now let us discuss about the sharp edge propulsion system. So, as far as the sharp edge propulsion system are concerned, so these are the different configurations which are available under this sharp edge propulsion system. So, ideally in this system, so we have a kind of a structure which is placed over here, and then the overall control over the propulsion velocity and the wave velocities are appropriately controlled. So, with reference to propulsion velocity is concerned, like it is manipulated or it is propelled by the wave velocity, which is a kind of a sharp object. So, in order to get a kind of a no moment condition, so ideally we may need to go for such kind of feature, or in case if we need to move along a direction, so we may need to have a wobbling kind of arrangement. So, this wobbling will have two sets of configuration. One is in the form of a clockwise direction and the other one is in the form of an anti-clockwise direction. So, moving or by wobbling in both clockwise and an anti-clockwise condition, so we can expect a kind of a propulsion in a forward stroke. So, when we try to observe the overall schematic, this is called as a helical wave propulsion. In fact, we have discussed about this in the last module also. And then it's a kind of a micro scale swimming robot with a kind of a wave propulsion. So these are some of the different designs with sharp edges, so that these sharp edges will be a kind of a point of contact with the micro bubbles. So as and when micro bubbles starts interacting with these sharp objects, appropriately we can observe a kind of a propulsion which can be easily monitored easily observed using this system. Okay, so this is a kind of a configuration which is called as a sharp edge propulsion. Now this is called as an in situ micro rotor. As far as in this in situ micro rotor is concerned, so the overall configuration, like if you see the shape of this micro rotor, so appropriately it can create a kind. So when we try to give a kind of a micro bubble propulsion in different orientation, appropriately we can expect a kind of a angular displacement which exhibits in this micro rotor. So wherever we are more concerned about the angular rotation, so such kind of in situ micro rotors are deployed. So here in this particular case, so we have a pillar kind of arrangement, and then there is in order to take care of the micro streaming, so we have a micro bubble which is being placed, and there are some sharp edge corners which are available. So at the edge of these sharp edge corners, so we have a micro bubbles which will start interacting at these sharp edge corners. So appropriately we can expect a kind of a rotation which exhibits. So this rotation will try to propel the will propel in a angular rotation form, and this can be used for a kind of a targeted drug delivery, or in certain cases this can also be used for a kind of a micro rotation, or a kind of a vortex generation can also be created using such kind of structures. Now let us discuss about the different types of propulsions, and especially with reference to acoustic based system. So as far as in this acoustic based system, so when we try to classify the propulsion type, so we have a bubble propulsion system. So the overall principle involved in it is the bubble vibration produces a source of net momentum, As far as advantages perspective point of view, it is fast and it has a strong propulsion. With reference to disadvantages perspective point of view, it has a narrow frequency selection ranges and bubbles may burst and it might be a hand operated system. As far as sharp edge propulsion is concerned, the sharp edge vibration generates a propulsion, wide frequency selection range and a simple manufacturing operations. With reference to limitation perspective point of view, it has a kind of a low propulsion. So wherever we have a limitation in the propulsion, so there we will be using such kind of sharp edge propulsion. Next, with reference to in situ micromotor perspective point of view, so this is also similar to a sharp edge propulsion, but there is a kind of a fixed axis in the center. So there is a kind of an in situ propulsion and a low fluid influence which exhibits. With reference to disadvantage perspective point of view, it can create a kind of a complex design. Now let us see some of the applications related to this acoustic based system. One of the key applications which are involved is a kind of a microfluidic configuration. So let us consider a kind of a PDMS structure or a PDMS channel which is placed, and here so there are some fluorescent particles are there. So the main motto of this particular structure is the fluorescent particle has to reach a particular portion and it has to stick on to some layers. For instance, a tissue is affected by cancer, and if we need to have a kind of a imaging, so we may need to appropriately propel this fluorescent particle, and we direct the fluorescent particle directly to stick onto the tissue so that it gets sticked onto the tissue, and appropriately we can have a kind of a emission coming out of it. So here in this particular case is concerned, so this is a kind of a bubble region which is a kind of a PDMS structure, and these bubble regions will take care of the direction as well as it takes care of the propulsion of these structures to achieve the required functionality. Now this is a kind of a microsurgery. So as far as in this, it's a kind of a bio-inspired acoustic magnetic micro swarm. So in this particular case, so there are some bacterials and then there is a bio-inspired structures which are available. So here, in order to create a kind of a acoustic based structure, so a piezo transducer is used. So this piezo transducer will vibrate at a high frequency, and this frequency will be creating a kind of a vibration which is a kind of a pressure node which exists. From this pressure node, there will be a kind of a force which will be generated out of it. This force is capable enough for transferring the structure from one particular portion to another particular portion. So ideally, there is a kind of a shear flow which participate in this, and then there is going to be a capillary structure which will be participating in it for an appropriate movement of the flow. So in the next module, so we will discuss about the bio-inspired fibrillar based adhesive structures and how these structures work upon and how these structures actuates with reference to different configuration. Let us discuss in detail in the upcoming lecture.